Hi, and welcome back to ZCon 2, the light edition, the virtual edition that we're holding this year. We have put together a panel to talk about hardware security modules and hardware wallets. So as I'm sure everybody who's watching this is aware, hardware wallets manufactured by companies like Ledger and Trezor have become very popular for people who want to hold and secure their own cryptocurrency funds. And at the enterprise level, at custodians and at exchanges, they use a similar type of technology, just slightly bigger and more expensive, which is referred to as hardware security modules. Now, one of the great things about the fact that Zcash was built on top of the Bitcoin code base is that it was very easy to add support to these devices for transparent Zcash. However, that's not necessarily the case when it comes to the new zero-knowledge based cryptography that's used for shielded transactions. And we worry that that is an important hurdle to more widespread adoption of shielded Zcash by custodians and at exchanges. So we've put together a panel today to talk about whether this is in fact the case and to talk about some of the challenges that, developers face when they're trying to add support for shielded Zcash functionality to these hardware devices. I'll let the panel introduce themselves, starting off with Juan.
Thank you, Jack, for the opportunity. So my name is Juan. I'm part of and leading Sondax. Sondax, we're behind of many of the hardware wallet apps and integrations that people use every day for many of the top coins. And we typically work in this area like cryptography, remote signers, exchange integration, and protocol development. So I'm happy to kind of share the panel and hopefully contribute with some ideas.
Hi everyone, I'm Conrado. I started studying cryptography during my master's PhD, and then after that I worked for 8 years in the industry, and a large part of that was in the software, developing software for a HSM. So our company had a HSM, and I participated in that project since the start. So I think it was a very interesting experience. HSMs are kind of rare. So yeah, looking forward to, and now I joined the Zcash Foundation a little more than 1 month ago. So still learning a lot, but looking forward to both working Zcash and trying to help on the integration with hardware wallets and HSMs.
Hey there, my name is Dan. I am a software engineer at Gemini, and I believe I'm here today as kind of talking about my experience at Gemini, as we are heavy users of hardware security modules. As a kind of context for background, I am not a cryptographer, just a software engineer, but I guess I have increasingly specialized in recent years on interacting with cryptographic hardware. Day-to-day is kind of a lot of collaboration with the security engineering team, but I come at this from just kind of a software engineering perspective. Yeah, and so hope to share some insights, personal opinions, not necessarily corporate ones, but yeah, excited to speak on this panel.
Hi everyone, I'm Steve. I've been involved in the Zcash community for quite a while now. I'm primarily active on the forums. My history is I come from primarily a test background, a test engineering background, and I used to work for a large HSM manufacturer, and I spent my time there testing data cryptors and payment hardware security modules and network hardware security modules. Yeah, and I look forward to this discussion.
Thanks all. So to get us started off, Daniel, can you talk a bit about how important hardware security modules are for exchanges and how important HSM compatibility is in terms of making it possible for exchanges to support shielded Zcash deposits and custody? Obviously, there are regulatory issues that would need to be addressed, compliance and so on. But if we're talking about it purely from a technical and security perspective, what are some of the issues there?
Sure. So one of the main properties that a hardware security module gives us, and I guess it gives it to a greater degree than other cryptographic hardware, would be non-extractability. The keys are generated on board the device, and the device effectively promises, I will never release this secret material. I'll let you sign with it. You can sign whatever you want, subject to, I guess, how you interact with the system, the sort of the other governance that goes beyond it. But fundamentally, this is a black box that says, I'm holding onto the secret and I'll never release it. And there are other ways of getting that through other cryptographic hardware, but that, I guess, is the main selling point of what it's really providing. So Gemini provides withdrawals to shielded addresses. It does not currently provide deposits to shielded addresses. And HSMs, I guess, in some sense, are a roadblock to making that happen. And if we were to support deposits to shielded addresses, we would not be executing that crypto in the HSM. Vast majority of HSMs, in fact, I'm not aware of any HSMs that would support this cryptography out of the box. So you're really looking at the subset of vendors that would give you a device where you can provide firmware extensions or some other way of loading custom code. So yeah, it's a major technical hurdle. One could imagine a scenario where signing control and shielding is kind of separated in some technical sense, where simpler cryptography could be HSM supported, and thus there's kind of like a, I don't know, co-signing, co-processor model of having some part of the signing within the HSM and more of the complexity outside the HSM. I guess a hybrid model there. I don't know enough about exactly how the crypto in the various iterations of Zcash works to say if that's a feasible thing to do, but it's kind of one thing that's been in our minds about how to kind of bridge that gap. My personal sense is that HSM vendors are very conservative in what they provide. We, as a industry of cryptocurrency, are kind of relatively small, and RSA and ECDSA covers a lot of the use cases for everybody else. So there's not a great motivation other than seeming forward-looking to add in new crypto. They have their roadmaps all planned out, and interesting cryptography is not typically on there. So yeah, I guess it's a good conversation to have. I'm glad to kind of be giving our take on it today. I hope that answers the question. I think I started somewhere at the beginning and I lost your thread somewhere in the middle.
It sounds, from what you said, like being able to sign these transactions, being able to protect those keys in a hardware security module is a very important factor in being able to support a given cryptocurrency, or in our case, the shielded transactions. Like, would you say that it's unlikely for an exchange to be able, a well-run exchange like Gemini, without putting you on the spot, to be able to support shielded custody and shielded deposits without there being support for that functionality within the HSM hardware that exchange uses?
All right, we're going to cross from any corporate statements to personal opinions here. I would say that, and I guess I was trying to hint at that in my earlier statement, that HSMs are not the only way of achieving non-extractability and other properties that you would want. It's kind of memory protection so that you can't, I don't know, get out some cold liquid and try and scrape keys off of silicon, or crazy attacks like that. There are TPMs, there are various trusted execution environment technologies, SGX from Intel, AMD Sev, Amazon Nitro enclaves, the list goes on. There are many ways of kind of building those sorts of systems. And I guess you could just argue to the degree at which you are getting some guarantee about non-extractability or memory protection. So I don't think it's a HSM or nothing else sort of discussion here. And you could imagine, and again, I guess what I was trying to hint at earlier was that the HSM might be required as part of the process, but it does not govern the entirety of the process. Maybe the key material is bound to the HSM, but it will release it into a weaker execution environment for the duration that it's needed, but it's kind of providing some security at rest, for example. You're still leveraging all the governance that you would get out of an HSM, which is kind of requiring proof of presence, a certain number of people being there to operate the device. At rest, you have all the guarantees that you would get out of an HSM. So I think the design space is subtle. There's a lot of complexity into what you could build here. But in the short term, my view is you are not going to get the entire system running in an HSM unless you write it entirely as your own custom firmware, at which point you're kind of compromising your FIPS rating, or you somehow convince a vendor to blow up their roadmap and implement cryptography that you guys are coming up with all the time. I don't really see the latter as viable.
Fair enough. Well, it's good to hear that it's not a complete showstopper for shielded support. Well, on the topic of being able, to write one's own firmware, Zondex recently completed the development work for adding support for Sapling Z addresses to the Ledger hardware wallet. Can you talk a bit about what that process was like and how difficult it was to be able to squeeze that functionality into the Ledger device?
Sure, of course. I mean, to be fair, I would say that was a perfect puzzle for COVID times. We worked on this along 2020, so we had like a lot of time to go into a rabbit hole. I mean, the challenges initially were clear. I mean, it was like more related to kind of like re-implementing some of the primitives, checking how we could fit the existing implementation into amount of memory that we had in these consumer devices that are different from the kind of HSMs, and the use case that you have in mind in that case is different from what Daniel was like describing. I mean, it's not only about like keeping the keys safe, but the third model is like you should be able to go into a compromised host, like a computer in a cyber cafe where you have to assume that it has been compromised. You should be able to sign and independently verify what is the content of the message that you want to sign. So it's not just about like keeping the keys, but also we need to be sure that the users at the point that signing, they know what they're signing. So this was the initial kind of like challenge and feeling. But to be fair, that was not really where we spent most of the time. In certain ways, this might feel like flipping the topic a bit, but because it was what happened during our development, the major challenge was not so much about key generation and signing and keeping the keys safe. It was about like 2 or 3 additional topics that are kind of like not that obvious in Zcash, but they are like where the challenges were to us. So in one case, the computing power of these consumer devices is not enough to run proofs. And also, in order to know the balance that you have on chain, you need to decrypt a lot of the messages that are on chain, which is really a large amount of messages. So that means that the hardware needs to be able not to sign, but to decrypt really, really fast the chain in order to tell you what your balance is. In order to do that, if you do it on the hardware, then you need a lot of compute power. Otherwise, you have to give away the key to some, as Daniel was saying, some trusted execution environment or some like host that you can trust in order to do this decryption. That was one of the first challenges we hit, and we didn't recognize that at first. we thought, okay, this is more like key generation and signing, like a typical HSM or hardware wallet issue or like challenge. But the decryption was a problem. Obviously, the hardware wallet, like a consumer device, is not able to decrypt fast enough to tell you, okay, these are the 10 transactions that apply to you in this whole amount of things that happened in the last number of years. And the other big challenge was proof generation, where in order to generate a proof for certain transaction, you have to give away also key material to something that is more powerful. So in a way, while we could manage to get all the workflow working, like sign and everything, I think it's still a bit of an open problem from the consumer devices point of view, how you can get shielded addresses and still give privacy warranties with respect to the key material. Because in many cases, the viewing keys need to get out of the device, and then privacy, even though you have this hardware wallet where you can keep your keys in a safe situation, you don't really have a kind of 100% privacy assurance, because you need to give away part of the computation to a host that could be compromised. And so I guess that in certain ways, the only solution we see at the moment is more towards a kind of hybrid solution where you need to have some kind of component outside that has to be, or a trusted execution environment or something that you can actually trust to be sure that your privacy is not compromised in these consumer areas. In the case of exchanges, maybe this is not so critical because exchanges anyway, they have to do KYC and they have to do other things. So the privacy is not 100% when you are inside an exchange. But I think that that's something that we found like quite challenging. And I think the other challenge that we have at the moment, and probably that will come up a bit later during this talk, I hope, I don't know, is that useful today? I mean, can we use the hardware wallet implementation today? And that was another challenge, is how do we integrate the result of our work into an existing software? In many cases, many people are used to use web browsers, but today we cannot run proofs on web browsers. So the only way you could use our implementation for the Ledger app, it's in a desktop application, and we need to start like some collaboration with existing desktop applications in the Zcash world in order to get this integration going on. So in the end, the challenge was a bit beyond the typical key generation and signing. It was more in different areas that were a bit unexpected to us.
Yeah, I was curious as to whether viewing keys would be a solution there, but I guess even then you're facing trade-offs in terms of the need to store those somewhere, and if they get compromised, then your privacy is pierced. But at least if you keep the spending authority on the hardware device, then that's protected. Your funds are safe. So Steve, obviously it would be great for us if hardware manufacturers included firmware support for the cryptographic functions and algorithms that Zcash relies on. So how difficult is it to persuade them to add new crypto functions? You know, Daniel has just alluded to the fact that you've got to get them to add it to the roadmap. So it doesn't sound like it's a trivial exercise.
Well, it depends who you work with. The companies have different solutions for different customers. So what level of HSM you can get will differ. So there'll be one massive company and they'll own lots of smaller companies, but they'll brand them all differently, and each aims at a different consumer segment. So if you're looking at the corporate end of this, you'll not find a payment HSM, one that does like credit card payments, that will be powerful enough to do zero knowledge proofs. You'll have to use a network HSM. Now, a company like Thales will help you with this. They'll actually do it for you. You can approach Thales and they will help you write because the hardware is so constrained and the operating systems they use are not like a normal operating system. They will help you write it. They will help you write the code, and then you can then try and license it out yourself, but it won't become standard unless so maybe the major grants committee will pay for it to go through FIPS testing or something, but they won't. It's very hard to, you're not going to be able to sit down and speak to them into it. You're going to have to pay money. But if you pay money, if you do it once and you go around and you find out what HSMs, they won't tell you really, but if you can try and find out what HSMs people are using, you could produce the plugin yourself. You could then get that professionally audited by the company that made it, and then by a proper auditing company. So it's not just security testing, it's actual auditing. And then you can give that to exchanges, but it would only work on certain HSMs because you need an amount of power, as everyone here has alluded to. Their zero knowledge proofs take a lot of work, even with all the great work the ECC's done in them so far. Yeah.
And how many different sort of brands, or how many, you know, I've heard that a lot of these devices, they all use, or many of them use the same chips inside them. So how many different sort of platforms are we talking about here?
Yeah, well, realistically, the main player is Thales, and then Thales own Encipher. Who else? They've bought everyone. They bought SafeMove. They've bought. I've forgotten. But yeah, so Thales will make a product and they'll reskin it for a lot of people. And then they go around and they buy up the competition. And the reason why they can get away with buying up the competition is because the competition isn't producing for the same market segment. So the part of Thales I worked for did defense stuff. But then that all because it's defense, it all has to be done in a sealed off little room where nothing's connected to the internet, and it's all, and we had to use FPGAs because we needed the power in them. But then stuff like Encipher will do business cases, and Thales in Western Florida will do the payment HSMs. So you're looking at maybe 4 big companies. Oh, Gemalto is also now part of Thales as well. Yeah, you're looking at maybe four big companies that are running everything. So your best bet is to find out what they're using, is to try and find out what the exchanges are using.
Conrado, obviously you've a lot of experience of actually writing software for these devices, and I'm conscious that you've not been part of the Zcash, you know, family for very long, but based on what you've seen so far, what do you see as being some of the obstacles and hurdles, you know, in bringing support or writing that firmware to bring shielded Zcash to those hardware devices?
Yeah, the main issue is the algorithms, right? Since the cache use pretty unique algorithms for security reasons, and for, of course, to actually allow zero knowledge proofs, it uses pretty unique algorithms. So, of course, most HSMs, they all support the RSA, SDSA, the basic stuff. And so that, of course, is a challenge. One thing that can make that easier, it's something that Daniel already mentioned, is that in order to actually authorize a transaction, Zcash, a shielded transaction, you actually only need to sign to create a red DSA signature. The other parts, which is decrypting and generating the proof, of course, in the best scenario would be to do everything inside the hardware, but you can do outside, and you need to export the viewing key for that, but you won't risk someone spending your Zcash. So the worst case scenario, you lose some confidentiality, but no one would be able to spend your Zcash. So that's one alternative. But yeah, you still have to put the red DSA signature inside the hardware, and this is the hard part. This is a unique algorithm which is based on ED-DSA, which is kind of common right now, but I think some HSMs support them, but I'm not sure how many of them support it. But still, it's not pure DSA. It's a version of the DSA that supports key re-randomization. So yeah, the main challenge is it's somehow changing the firmware, the HSM firmware or the hardware wallet firmware to support these operations. And of course, RedDCA is based on elliptic curve cryptography, so you have to support, for example, for the Sapling, you need the jub curve, and for Orchard, you need the Palace curve. So each one of them has also unique curves which are not used. I think maybe I'm not aware of any use outside of Zcash. Probably there are some, but they're not very well known yet. So yeah, it's possible, but it has some issues regarding adoption. So to solve that, there are mainly two approaches. Some HSMs, they support a feature. There's no a single name for that, but a secure execution of applications, where basically you can provide your own application to run inside a trusted environment inside the HSM. So that would be probably a good solution. So you write your own software, so everything's up to you. That could be a good solution. And the other alternative would be to really integrate these algorithms inside the HSM firmware. So like Steve was mentioning, you could approach some vendor and discuss with them that possibility. But of course, again, like Steve mentioned, there's a few players. Thales bought everyone else, so you have very restricted options. But something that's worth mentioning is that because of that, there are some smaller vendors. For example, the place that I work at in Brazil, there's also another vendor here in Brazil, and probably there are other countries which are smaller. And they start to get some attention because, you know, companies that use HSMs, they are worried that Thales owns everything. They don't want to be locked in on a single vendor. So there's some interest on alternative vendors of HSMs. And so these smaller companies are very eager to find new clients, find new features for HSMs to make them more attractive. So I think that's a good opportunity to approach the smaller companies and try to come up with some partnership to include these algorithms. Because the algorithms themselves, of course, cryptography is always tricky to implement, but there's a lot of, Zcash team, Zebra team, they're working on implementations which are open source. So for the point of view of the HSM manufacturer, they just need to integrate that algorithm into the firmware. So I think the integration itself wouldn't be that hard. It's just finding some manufacturer, some vendor that is willing to do it. Yeah.
And Steve, from what you said, it sounds like getting that FIPS, getting that auditing done is quite an important part of the process. You know, what and you may not know the answer to this, but what sort of ballpark cost are we talking about there for that sort of work?
To do the actual FIPS testing?
Yeah,
I can't tell you off the top of my head. I don't.
Okay.
It's millions, I think, to submit.
Oh wow.
I'm not 100% sure, but you might not need it. This is kind of a question for Dan. I'm not sure if he can answer this, but I was wondering, are there HSMs for Zcash single-use devices? So do they only do Zcash, or do they also do other cryptos or other types of payments as well? Or is it just a Zcash HSM? Because that would make a difference to how you handle that.
So I didn't quite follow your last question. That you were asking if we used an HSM specifically for Zcash, or? Yeah.
So when you send out your transactions, your transactions, that HSM that does it, does it only do Zcash, or could that also send out a Bitcoin transaction? And could it send out an Ethereum transaction, or could it send out a Visa transaction, or does it only do Zcash?
So right now, the HSM is not involved in well, we support transparent deposit addresses only. We support sending to shielded addresses, but there is no HSM involvement in shielding in any sense. So yeah, we are using Zcash just like we use Bitcoin in sort of legacy mode, effectively.
Interesting. Okay. Well, yeah. In that case, you could probably you could just put all this on a network HSM and not worry about FIPS testing, and then people could just use it as a payment device that way. And then because the FIPS testing only really applies to cash. Obviously, you want FIPS testing, but you don't have to have it, but you might do for your insurance.
Yeah. So as we're getting into the topic of customization of HSMs, I mean, there are a number of vendors out there that do provide this to some degree. So SafeNet, I guess, then Gemalto, now Thales, if I've kind of followed the acquisition order correctly there. In their Luna product line, they have, I guess, what was it, SafeNet functionality modules, now sort of Luna functionality modules. These are, this is the ability, according to some sort of C, C++, GCC toolchain, to write modules of functionality that you can load into the secure execution environment of this product. So yeah, you can get done whatever you want to get done, but a number of things are a problem there. We're talking about FIPS. Yeah, so your FIPS statement kind of goes out the window because it's now not part of the kind of attested, reviewed HSM. You're on your own. I think it's still the case that high availability functionality of that system also turns off once you start loading your own modules. I guess that's more of an engineering concern. And some of the primitives, like the sort of accelerated primitives, are not available to you. That might then have an impact about the speed of execution. So they will have optimized point multiplication. And if you're just having to do your kind of software big number library to execute point multiplication, that's not going to be as fast as it would have been natively supported. So I believe SafeNet or Luna devices are Power PCs. Much of Zcash software is written in Rust. I believe that's a perfectly fine CPU architecture target. Utimarco is another HSM vendor that allows you to write custom firmware for it. Unfortunately, they've put some Texas Instruments digital signal processor in there as their CPU. That is definitely not able to be targeted by the Rust toolchain. So you're kind of out of luck there for compiling for that architecture. So yeah, as soon as you sort of dive into the details of trying to compile Rust libraries or Zcash libraries for some of these systems, you get into interesting architecture problems, toolchain problems. You're definitely kind of out on your own there. And then there's questions of kind of performance too. So it is definitely not plain sailing if you're going to put more software into HSMs. Yeah.
We've had some questions come through from the Discord, and here's one that I think Juan might be able to answer. Do we know from talking to hardware wallet vendors what fraction of users or traffic use Zcash currently? The answer may be in the realm of possible user stats tracking the operator avoids for privacy. I'm not sure what that means, but yeah, Juan, in your travels in this space, have you gained any idea of how widely people use the hardware devices for, I guess, transparent Zcash at the moment?
I mean, unfortunately, I don't have that kind of information because that would be, I mean, something that we are not even in touch with. I mean, we typically provide the applications, they get published, and the applications can be used by anyone. We don't have any kind of tracking or information about that. Unfortunately, yeah. I mean, I don't know.
And I don't know is a valid answer to any question. That's fine. Here's one that I think actually, given his handle, Steve might be able to answer. Are there any HSMs that include reprogrammable logic, i.e. FPGAs, to support new algorithms?
Yeah, most high-end ones do. Like, for example, the Luna does, and they will actually program the FPGAs for you, and they get good DDR4 memory in it. You can get them in different formats as well. So you can get PCIe cards to put it in, so you can have it actually in a PC next to a trusted computing platform, a DPM module. So that might be one solution that might help somebody.
I would add something to this discussion of the Thales HSMs, because something that maybe is not so well known is that actually the implementations that you make for Ledger devices are fully transferable to Thales modules. I mean, actually, there are some experiments where you can like run the same kind of like, it's a bit of, I would describe that as virtualized, but you can like run Ledger applications into Thales modules without like a lot of trouble. So I mean, it's not that what we were discussing is that it's impossible. I mean, running something in Thales, like for example, the implementation that we have should be relatively possible. But again, we are in the same situation I described before. It's not just, obviously maybe for an exchange might be enough, but it's not just all like signing, it's all like where to generate the proof. And that's where the real challenge for me is. It's not the curves, it's not the signing, is the proof generation that can be like really difficult. And then we need to kind of like go into some solution like what Daniel was describing, where you need some hybrid system with some trusted execution environment or something that you can like delegate the proof generation to.
So Juan, the way that the Zcash protocol is designed at the moment, and I appreciate you're probably primarily only familiar with Sapling, does that design, does the way it's constructed, lend itself to that sort of hybrid model, or is it just awkward and difficult? Is there anything that that the protocol designers could do to make it easier to have that sort of hybrid HSM plus external proving environment?
So today, that's the implementation we have today. Basically, we had to kind of modify a bit the workflow in a Ledger device. So half of the, I mean, there is a lot of like interaction between the hardware device and the PC, and the proof is generated outside. The thing is that you have to transfer this key material, but apart from that, it's already happening. And if we had like some kind of like implementation in an ARM CPU or SGX is not like kind of my favorite, to be fair, but you could have some kind of like proof generation in a trusted execution environment. So that would be possible. Today, I think there are kind of like good solutions, even like the normal desktop wallet that we are all using in Zcash is doing that with the Rust implementation. So there is no issue there.
Okay. Conrado, based on what you've seen of Zcash so far, do you think that there are ways that we could make, or that the protocol could be designed in a way that makes it easier to build these sort of solutions?
Yeah, I think the way that exists right now, starting from Sapling, that permits this generating the proof outside is really good. But maybe there's some way to improve this problem of you have to export the viewing key to the host computer. Maybe there's some cryptographic way to add some assurance that the host computer won't be able to use the key to gather information about your transactions, but I'm not sure. But I think the current way that's right now, I think it's a really good compromise. So you keep the security, you keep the signing key inside the hardware, it never leaves the hardware. But maybe in the future we can find some way to improve this problem of loading some of the computation to an untrusted device.
Cool. Well, we're heading towards the end of our time. I just want to give anybody a chance to raise any points or ideas that they've had that we haven't already covered during the discussion.
I have a kind of random comment about FIPS certification. The main problem is that FIPS restricts what algorithms you can use when you operate in FIPS mode. So you can just RSA and CDSA and so on, and the algorithms that Zcash uses are not allowed. So even if you wanted, you couldn't get your device FIPS certificated. I mean, you can include the algorithm in the device, but it wouldn't be available in the FIPS mode of operation. So that kind of don't need to worry that much about FIPS. Only if you, for some reason, you have to, you need for, I don't know, for some regulatory reason, you have to use a HSM in FIPS mode, then you won't be able to support shielded Zcash. There's not much you can do. Yeah.
We can save the millions that would otherwise cost to get that assurance, given that it would be pointless anyway. Steve, I think you wanted to say something?
Yeah, I'd just like to ask Conrado, most of my experience with, well, in fact, all of my experience with HSMs, even the payment ones, they've all used real-time OSs. What's your experience been with that? And how do you think Zcash would work in that environment?
Yeah, in my previous experience, we just use a regular Linux operating system. So, I mean, if you were to add Zcash support to the HSM from the company that I worked on, it would be really easy. It was a PowerPC processor running a custom distribution of Linux. So yeah, we need to compile the Rust code into .so, a shared library, and you're good to go. Just integrate with the farmer. So yeah, that depends a lot on the vendor, right? But from my personal experience, would be kind of easy.
Okay.
I want to throw out a maybe a contrarian view right at the end here of I guess we've all been talking from the perspective of let's put more and more into HSMs, or let's put more and more into kind of secure execution environments. That's going to make it harder to deploy that code, to maintain that code, particularly if you, I don't know, bury your HSMs somewhere. The harder you make that to go through the regular forks that occur in Zcash, like the more kind of headaches you're giving yourself. So it's worth thinking from the kind of the engineering perspective of the poor software engineer who's like trying to deal with the next Zcash fork of like, oh no, I put all this code in a place that's really hard to upgrade. Is that a good idea? More and more code is going into a more and more sensitive place, which is touching the key material that we're trying to protect. Maybe you want to put less of it there. So I think that really speaks to being thoughtful about exactly how much of the protocol you actually want to put in a more difficult to deploy to, difficult to program, difficult to test environment. Maybe you don't want to have everything in the HSM.
Or make it as little as possible. Well, we are out of time, but I'd like to thank everybody. This has certainly been educational for me. It's it's an area that I think unless you've worked in it, it's a bit of a black box. So thank you very much for taking the time to speak with us on this. Next up on ZCon, I think we have a session on the Orchard Shielded Pool featuring Halo 2, and that'll be coming up in 10 minutes or so. But for now, from this particular panel, thank you very much, and good evening, good day, good night, depending upon where you are.
Thank you, everyone.
Thank you very much.
We're out.
And we're out.